Welcome to Learning with Philemon. In the next few videos, we will be exploring the concept of isomerism. Isomerism is the phenomenon in which two or more compounds have the same molecular formula but different structures. This could either be due to a different arrangement of bonds or a different spatial arrangement of atoms. There are different types of isomerism, as can be seen in the diagram below. In today's video, we will focus only on structural isomerism, in which compounds have the same molecular formula but differ in the arrangement of the atoms. In other words, the atoms are bonded in a different order. There are three types of structural isomerism: chain, positional, and functional. Let's start by looking at chain isomers. In chain isomerism, the carbon atoms are rearranged, leading to branched carbon chains on the main chain. For example, butane and 2-methylpropane have the same molecular formula, C4H10. Note that this means that they contain the same number of atoms of each element, 4 carbon and 10 hydrogen atoms in this case. In butane, the carbon atoms are arranged in one chain of 4. 1, 2, 3, 4. In 2-methylpropane, there are 3 carbon atoms in one chain. 1, 2, 3. And there is a branch of 1 carbon atom. There is a methyl CH3 group on the second carbon. To see why this compound is called 2-methylpropane, watch the video IUPAC naming of substituted alkanes. When asked to draw isomers with the molecular formula C4H10, students often draw the following. There are 2 ways to show that this is not another isomer, but in fact butane. One way is to build the molecule using a molymod. Because single bonds are able to rotate, this molecule is not stuck in this configuration. If the bond rotates, then the carbon is in this position and the hydrogen is in this position, just as in this diagram. On the other hand, to convert 2-methylpropane to butane using the molymods, you would have to break and form a few bonds. They are not interconvertible via the rotation of bonds. The second way to figure out that this is not another isomer is by naming it. The longest chain in this molecule is also 4. 1, 2, 3, 4. So this molecule is also in fact butane, not another possible isomer. The longer the alkane, the more possible isomers there are. Can you draw and name all the possible chain isomers for the molecular formula C6H14? Pause the video if you do not want to see the answer straight away. Here are the 5 possible chain isomers drawn using the skeletal formulae: hexane, 2-methylpentane, 3-methylpentane, 2,3-dimethylbutane, and 2,2-dimethylbutane. Now let's have a look at positional isomers. In positional isomers, the only thing that changes is the position of a functional group. For example, the only difference between propan-1-ol and propan-2-ol is the position of the hydroxyl OH group. The OH group can be on carbon 1 or on carbon 2. Note that propan-3-ol is not another isomer. It is the same as propan-1-ol. Another example of a positional isomer pair is but-1-ene and but-2-ene. In this case, the functional group is the carbon-carbon double bond. In but-1-ene, the first carbon-carbon bond is a double bond, whereas in but-2-ene, the second carbon-carbon bond is a double bond. Like in the chain isomer examples, the only way to convert one isomer to another is to break one or more bonds and form one or more new bonds. Now let's take a look at functional isomers. When atoms are bonded differently, this can lead to different functional groups in each molecule. 2 possible functional isomers with the molecular formula C3H6O are propanal and propanone. Propanal is an aldehyde with a carbon-oxygen double bond at the end of the molecule. Propanone is a ketone with a carbon-oxygen double bond in the central carbon. Because these functional isomers contain different functional groups, their chemical properties are different. We have seen both aldehydes and ketones in the oxidation and reduction videos. There are actually more functional isomers with the same molecular formula, albeit a bit more complicated. I challenge you to draw and name them. Thank you for listening. To consolidate your learning, try answering the questions in the description. If you haven't already, please subscribe for more content. Stay curious.